password on this computer. Okay, so anyway, as I was saying, this week we're going to move on to the next chapter. We might even cover chapters 3 and 4, but the idea is to move on to the next phase of the project. So far in your project that you've chosen, you should have figured out the problem, the problem statement of your project, which is essentially just figuring out what the project is by talking to whoever it is that you're doing the project for, and made a list of tasks that you think you would need, to general tasks, very general tasks that you think you need to do to complete this project. When I mean general, I mean quite general. We're talking about we don't want to be doing a project about building a bridge and talk about laying out a particular pattern for rebar or something, or deciding on a pattern for rebar. That's a little too specific, because the pattern that you use to lay out your rebar is going to be determined by design things that you haven't done yet. You have to first design the bridge before you decide on a pattern to lay out your rebar in. You also wouldn't you wouldn't necessarily put in laying or surfacing the bridge with asphalt, because you may not end up surfacing with asphalt in your design. In the process of designing the bridge, you may decide that concrete is better than asphalt, and so you don't want to make any design decisions in your list of tasks. What you want to do is have a good, I would say, 10 to 20 tasks, somewhere in that range, that are more like plan. One of the first things you might do is plan the teams. You might be looking to bring together some experts in different fields to give you some experience in different parts of building a bridge. Then you might also, that's a task. You're forming a team or putting together a team. One other task might be to do research on bridges in similar situations. So let's say you're building a bridge across a river with rock on both sides of the river. You might do some research on other bridges built across rivers with rock on both sides of the river. But we're not giving specifics. We're doing general tasks. And another task would certainly want to be research different materials that might be used or something, but that might be part of the design process. It's definitely something you need to do. So you just include that in overall preliminary design. You probably want to set aside some time for a task to do some deciding on which design is best. So maybe you'll put together 3 preliminary designs, and then you're going to spend some time evaluating the designs and figuring out which design is best for your project, or whatever. These kinds of very general tasks are what you want to do. You don't want to have any task on your task list that requires you to do any design first. You want to just have tasks that are going to have to be done. Eventually, you're going to have to build a prototype. That's a task. Eventually, you're going to have to test your prototype, and that's a task. Eventually, you're going to have to maybe do some redesign after you've tested your prototype and rebuild it or fix it or change it. Those are all things that you think you might have to do, and those are general tasks you're going to put on a task list. And then after the task list is complete, you're going to go ahead and you're going to calculate the expected time to complete those tasks. And there's a formula for that that's in the video. And it's a pretty simple formula where you estimate how long you think it'll take. You estimate an optimistic and a pessimistic time for the amount of time you think it would take, put them in the formula, calculate. Once you're done with that, then the next thing to do is to build a Gantt chart and a PERT chart, and all those things, all those parts of that are included in the chapter 2 homework. If you haven't done those things, just send me a note so that we can make sure that we move the chapter 2 homework so you can get those turned in. So that's what we've done so far. What we've done so far is essentially 4 things. Well, 5 things if you include the project logbook, which I didn't talk about yet. But the 4 things are, we've chosen a project, we've created a problem statement with the task list and the expected times. We've put together a Gantt chart, and then we put together a PERT chart. And instructions for doing those things are all in the videos previous, and they can also be found online. They're not hard. It's not hard to find tutorials on how to do any of those things online. Then the project logbook. Before we go any further, we are going to start a project logbook. You can use any online kind of document software you want to use, just so it can be shared with me, so I can see how you're doing and see how you're entering things in. I recommend Google Docs or Microsoft 365. There are others out there, but those are 2 simple ones that most people have access to. In fact, if you're a student at the college, you can have access to either of those easily. But the project logbook also has a video associated with it, and an example posted for you to look at. Remember that the project logbook is for any time you work on the project, you should enter something into the project logbook, particularly when you're doing something that needs to be remembered in order to get the project done properly. You need to enter that stuff in detail. So any lists of materials, any things that went wrong, you explain what went wrong, why it went wrong, how you fixed it, anything that you fixed and how you fixed it to make it work better should be in there. Any design drawings, any diagrams, any whatever you think is important to get the project done if somebody wanted to redo the project. And now we're going to actually step into the engineering design process and start designing. The designing part of the process takes up most of the process. And then we have kind of prototyping and testing will take up the end of the process. So now we're jumping into chapter 3. If you have the book, or if you have an electronic version of the book, chapter 3, you'll see. Oh, actually, we're not jumping into chapter 3. I forgot we're going to skip chapter 3. Chapter 3 is moral ethics and moral framework, which we will come back to, but it's not actually part of the process. So I'm going to skip. I mean, it is part of the process, but it's not. It's kind of indirectly part of the process, I guess. Pretty much what chapter 3 talks about is how you should be responsible for creating designs that are safe for users, safe for the society, and the ethics of doing that. But we're going to skip that and come back to it later. And chapter 4, we're going to go into, which is called identifying needs and gathering information. So we already talked about the need statement a little bit here, and here they go back into that, the need statement. They're reiterating the need statement. And that's, I think, fairly important. One of the things that's part of the need statement is to put together a list of a kind of a preliminary list of the requirements. And we actually make a few different versions of the list of requirements. And the reason that we do this is to make sure that we have all of the customers or all of the clients' ideas somewhere in one place, so that we know what they want from this thing we're designing for them. And sometimes it's called a design brief, sometimes it's called requirements list, sometimes it's called specifications list. I think probably the most common thing I've seen is called a specifications list, or just specifications in general. Try to find a specific one here for you. There is one in the book. I'm not sure if the older books have this particular one. I tend to think that they don't. But they have a design brief that is on in the new, sorry. In the new book, it's on page 116, but that doesn't mean anything for any older versions. But I'm going to go ahead and show you I'm going to bring up a design brief here that will hopefully be similar. Yeah.
Define customer requirements. Is it at the beginning of chapter 4?
Yep. Yep.
Table 4.1.
Yep. Is it called a design brief there?
Prioritize wheelchair retrieval.
Yeah, they're using a different one, but that's okay. It's still similar. Okay. I mean, here they give some basic ideas of what a design brief should be, the elements of a design brief. And there's lots of different versions of this in Google. Basically, what a design brief is it's going to include the description of the product or the description of the project, the thing that you're essentially, what it is that you're trying to do, what the problem that you're trying to solve, the thing you're trying to design. And that should be just a sentence or two that explains what you're trying to build and design. And I'm trying to find a good one that will whatever. There's so many different ways to do this. I'm trying to find one that's similar to the one in our book. That's not too bad. Okay, so here's one that's not too bad. Oh, it's gonna make me create a stupid create a. Okay, so here they just have some different sections here. So you have a project overview, which gives a description of the project, right? And here they say these are the kinds of things you want to include in that. What are we building? What design problem are we trying to solve? What assets are expected at the completion of the project? So what is this is an overall view of what we're trying to do with the project, right? The second part should have something to do with what you're trying to what this what the product should be used for, or how it's going to be useful. And here they're saying it's the goals and the objectives of the new design, right? So this is similar to the first part, but the first part is more general. The second part, we want to give a little more detail on what we want this to end up looking like, or end up being, essentially. Here they say an ideal outcome what would the ideal outcome look like? Are you redesigning an existing thing? So that would be important to include here. And it's the first time you've tried to tackle this problem, that could be included. But this is essentially the whys of why this project is being done. The overall goals of what you want it to accomplish. It's not necessarily about the design itself, like the first part was. This is more about what you want to do with it, I guess, is a best way to say that. And that's another thing that you could include in a design brief. And this part here in the book is actually covered in a couple of different things. You have the product description and then the product concept, which are kind of like the first thing. And then the product concept and the benefits to be delivered are kind of like the second thing. So it's like they've got 3 sections that cover these 2 sections. But the idea is to give a description of the project, a description of the thing you're trying to design, and then a description of what is going to be done with this. What is the purpose of it? And so those 2 things are good enough for that. And then we want to have some marketing things included. We want to know who's going to use it. What do we expect their, the demographics to look like? This is for old people. This is for students. This is for athletes, this, whatever. Or if it's multiple audiences, whatever. But also we want to know something about the economics of it. We want to know, is this going to be an expensive object that a company will buy one of and rent out, or this is something that everybody's going to carry on in their pocket? We want to have some information that's going to give us an idea of what how people will be using this, and in what situations. And a budget and schedule here down here. So this part here, we usually have a budget that is set by our client. We usually just don't have, as much money as we need, unless you're in the drug industry. But in this case, we have budget and schedule, so we have to choose the amount of money that we can use on the project, and then and that choice is usually made with our client. They tell us how much they can spend. We tell them how much we can do it for. Usually those numbers are fairly far apart, and we have to arrive at something in the middle. And then project deliverables. Now this becomes much more specific, and this comes mostly from the client. Project deliverables are the specifications. You want specifically for this bridge that you're designing to be able to handle 400 semis at so many kilograms per semi. You're giving very specific requirements under the project deliverables. I want you to design me a shopping cart that can turn corners at this radius and will not tip over if it has this much, mass stacked this high above it or whatever. I want you to build me a hose that can handle this kind of pressure with this kind of flow and will withstand, being exposed to sunlight for this many hours every summer, and so on and so forth. Your client will have specific requirements for the thing you're doing, and sometimes there's specific specifications like that. This much of this much of this. But sometimes the specifications are a little less specific. For example, you have a specification for your project with the Arduino that you want to take data with voltage, and do we know the range of voltage yet? Well, maybe not. So we need to find that. They say, well, we want you to be able to measure voltage, but you can't just measure any voltage with any circuit. You have to know the range of voltages. How much voltage, how little voltage. You might specifically need to know other things about the project as well. You might need to know something about ergonomics. How do they want it to be interfaced with the human user? If you want them to connect it to a computer and use the computer interface with it, or do you want them to be able to interface with it directly? Does there need to be some kind of control on it directly? So ergonomics mean a lot of things. That's very important to be specified how they want that to happen. These kinds of things, these specific requirements need to be sought after now. And this is where we're taking a step, going from the more general to the more specific. When we made our problem statement initially, and we started writing out a task list, we were just kind of getting ready for the project to start. But now we're actually going to the client, and we're going to start the project and ask specific questions. And when those specific questions yield answers that encourage us to ask more questions, we're going to ask those questions. Now, we don't want to ask so many questions that the client's just going, well, I don't know. I don't think that matters. Once the client says it doesn't matter, or they just don't know, that's for you to decide from then on out. you'll go and make those decisions and bring those decisions back to the client for approval. And there will be many more decisions that you will make as an engineer than you will get, as pieces of information from the client. The client will usually give you, a handful of requirements, and you will end up filling in, hundreds of requirements that make those requirements possible. Right? So those kinds of things are all part of this this specifications table, or whatever you want, design brief, whatever you want to call it. Doesn't really matter what it's called. Then the last thing is other relevant information. So if there's anything else that needs to be included, make sure that it's included. One of the things that I like to include in a design brief or a specifications table is things that the customer wants but are not required. Things that the customer would like to happen, but if they don't happen, it's not the end of the world. And so we'll sit down and have a discussion with the client about those kinds of things. And they'll say, oh, I hope it could do this, but I know that might be difficult to do. Or could it do this? Is there a way that you can make it do this? One of the things that you should probably never do as an engineer is promise people things that you're not absolutely sure about, that you've not done before. But if you think you can do it, you could say, we'll take a look at that. We'll do some research in that, and we'll see what we can put together. Right?
Now, I did have a question about our country. I think that it's scheduled in the
It certainly is, but usually that's how you start. Usually you meet your client once, and that's not always true in today's world. Sometimes you never meet them because they're in, Madagascar and you're in Nebraska. So you may never meet them. But if you can, it's, I think, best to meet them at least once. It just gives you a point of reference. I think it makes it a little more human. I think it's important to keep that aspect of things if you can.
I mean, for example, we're not going to schedule a meeting just because we have one single question.
No, that's a great thing for email. Email is, so you may not know this, but email was invented for this purpose. Did you know that?
Right.
Did you know that email was invented because of this? So the internet was invented by the Department of Defense during World War II. And it was, well, not really invented during World War II. It was kind of invented during World War. Well, really, it was. They invented the internet in World War II by the Department of Defense didn't actually exist at that time. But the War Department, as it was called, I think, they connected 3 different laboratories together that were working on the nuclear bomb at the time, so that the engineers and the scientists that were working on that could all share information and communicate back and forth. And the purpose of this was to communicate back and forth securely, so that nobody could get on the phone line and kind of listen in, So they communicated securely using different communication, computer-like, I'll say, communications across the country, because they had laboratories in New York and New Mexico and North Carolina. No, Kentucky. Where's Oak Ridge? Kentucky. Yeah, Kentucky. So they had these 3 different laboratories working on the nuclear bomb, and they needed to communicate back and forth. So they invented the internet as we know it today. It's a little bit different. And that persisted. They kept using it and kept upgrading it until it became what we have today. But email was literally invented for this purpose. That was the beginnings of email. So yeah, so definitely use email for this. All right, so your first task this week is to put together a design brief or a specifications table. The purpose of this is to then start the design process in kind of a visual way. So later on in the chapter here, in chapter 4, they talk about the objective tree. Okay. And the objective tree is a way of organizing what you're going to do, or it's a way of organizing how you're going to put these specifications into your design, I guess, is a good way of thinking, or how it's a way of organizing your specifications in your design table or your design brief. So let's take a look at objective trees really quick. And we looked at these very quickly
Yeah,
a couple of weeks ago.
we branch out.
So here is an objective tree. In this particular objective tree, they're designing a PAC. I don't really know what that is, but it's something. Anyway, in this particular objective tree, they start at the top with the title, which is what you should start with. You should start with either a simplified title. You can put a more complex title in there if you want. Here they have, this is the PAC, and then it branches out. And what they've done is they've organized at the very bottom of all these branches, you have all of your specifications. And they're not necessarily in great detail down here. These are specifications that are a little bit more general. So for example, one of the things that's specified is that it needs to be low cost materials. Now you could put in an actual number there. You could say, well, the client says $500 or less or something like that. And you could put that number in there. But you don't have to put it in there because that's on the list elsewhere if you want to keep it there. But there's also low selling price. Well, those two objectives or those two requirements from your client are similar, right? Because the low cost materials and low selling price will be related to each other. And so what they've done is they've created an affordability subsection here. And then they've put that under a cost effectiveness subsection because there's also low maintenance cost, which is not really related to affordability, but it kind of is related to cost effectiveness in general. It's not related to the original price of the product, but it is an ongoing cost effectiveness thing. So then they've got cost effectiveness, which covers both of those subcategories, and cost effectiveness is a main category under PAC. And then you have integrity, which covers, if you go down to the bottom of integrity here, you can see that there are 1, 2, 3, looks like 3 different requirements down here. Effective protection of babies, baby safety, and safety of workers and parents. Okay, so since I don't know what a PAC is, I don't know why baby safety and effective protection of babies is different. I think this is a.
I looked it up and it said,
That's what a PAC is for this project. It's a device. Do you know what a political action committee is?
No,
It's a stupid political thing.
yeah. No, a PAC has something to do with babies breathing, I believe. So I think it's a breathing device. It could be a heart device or something.
premature atrial contraction.
Okay, so I know exactly what it is now. It's actually a band they put around their chest, and it measures their heartbeat and their lung and their breathing at the same time. Because my daughter wore one. I'm pretty sure that's what it
It's
is.
an extra heartbeat that occurs in the upper chamber.
No, that's not what it is. That's a different PAC. But this thing essentially, I think, monitors. I think it monitors babies that are struggling to breathe and have a heart. But anyway, have heart issues possibly. But anyway, the point is that would mean that you want it to be safe for the baby to use, but also you want the use of it to be safe, how it works to be safe for the baby, but you also don't want the baby to like tear it off and choke on it or something. So those are two different versions of safety. You want the operation to be safety, and you want the actual apparatus to be safe for the baby to be around. And so you would list those separately. One of them is for an efficiency thing, it turns out, and then another one is for safety. the baby's safety. Well, actually, the actual safety of the efficiency would be how it actually works to prevent the baby from dying from stopping breathing or something like this. But anyway, and then both of these, the safety and efficiency comes under integrity, which would be like the quality of the product, right? The integrity of the product would be the quality of the product, which is a main subsection. Now, why am I teaching you this backwards? Why am I starting at the bottom and going towards the top? Well, because that's actually the best way to organize these things. The best way is to start with all the requirements that you've been given and group them into subcategories and see if those subcategories come together into categories, and then try to build a table out of it, right? It's really kind of a little bit of trial and error. You end up moving some things around as you think about it and talk about it. A lot of the design process in engineering is talking about things, discussing things, deciding on, how things should go, and moving them around in some kind of organizational structure, like this objective tree. They have two more categories, and in this, they have convenience and ease of use, and those ones don't have any subcategories. They just have the requirements at the bottom. Now, this is one way to do a diagram like this. Another way that I have seen before, let me get my drawing tools out here and I'll create a new one. On drawing tools, here we go. So another way that I've seen this done, if I was going to redraw this one here, and I redraw this middle one, the integrity one. Another way that I've seen this done is you have the PAC at the top, and then you have integrity underneath it like this, and then you have your efficiency here and your safety here. And then instead of having them all lined up below it, so this one would have just one below it because it only has one of them, but this one would have three below it that are side by side, kind of like a tree. This way it takes up more space, but people find it easier to follow often. So then you'd have the things going between them or whatever, like this. And this one would have three different ones going three different ways. And that's really the only other way that I've seen these done. I actually have seen them go sideways, but most of them go top to bottom. But once you have a list of specifications, you really need to organize those specifications into subgroups and groups and put them into an objective tree so that you can see all of the specifications or all the requirements from your client organized into categories where you can kind of keep track of them and see which ones are going to affect each other and be related to each other. In the textbook, they give an example of an automatic can crusher, which we've talked about before. And let me list off the list of requirements that they got from a client for this project. So the need statement says, design and build a device or machine that will crush aluminum cans. The device must be fully automatic. That is, all the operator needs to do is load cans into the device. The device should switch on automatically. The device should automatically crush the can, eject the crushed can, and switch off unless more cans are loaded. The following guidelines should be adhered to. So here are all the specifications from the client. The device must have a continuous can feeding mechanism. You might have more details there. You must be able to load in at least 10 cans at once or something like that, right? And that would be continuous. It can't be infinitely continuous. It can't just be this is connected to every can on the planet, and every can that's ever used on the planet falls into it. Right? Yeah. Right. So you might want to give some more details there. And if somebody tells you that, that's the kind of question, the follow-up question you should ask, right? The follow-up question you should ask is, well, what does continuous mean? Does that mean, 10 cans at once, or a big garbage bag a big garbage bag full of cans, and so on, right? Then the next need statement obviously an engineer was thinking well when they came up with the question that resulted in this, this part of the, in this requirement. Cans should be in good condition when supplied to the device, not dented, pressed, or slightly twisted. Because that will make a difference engineering wise on how you design things. So all the cans going into this are supposed to be in original condition, essentially, right? The can must be crushed to 1/5 of its original volume, right? So that's a very good thing to know. What is a crushed can? What constitutes a crushed can? 1/5 of its original volume. Maximum dimensions of the device should not exceed 20 by 20 by 10 centimeters. That is extremely important for most designs of any kind. If you're designing something physical, if there are requirements on the dimensions. If size matters, you need to know. It doesn't need to be smaller than this, doesn't need to be bigger than this, doesn't need to be between this size and this size. Sometimes even shape and color matter, right? And material sometimes matters. Because maybe they're integrating it into another design. Maybe they're building something that's going on their Ferrari F40, right? So they want it to look exactly like the Ferrari F40 or whatever. So external dimensions, external look, external materials, shape, range of sizes, all these things can matter. You have to consider those things and ask those questions in many cases. The next one is performance will be based on the number of cans crushed in 1 minute. So in other words, this client would like this thing to move quickly. It will be considered higher performance if it can crush more cans in a minute. Elementary age school children 5 and up must be able to operate the device safely. So that in almost every project, you have some statement of safety. The statement should include something to do with the user's safety and something to do with the machine safety and something to do with maybe with what the machine is doing safety, right? So safety for the machine itself so it doesn't break or damage in some way. Safety for whatever the process is the machine is doing, making sure that is safe for whatever and whoever. And then safety of any users or bystanders or anyone in the immediate vicinity. Many people would add safety to the environment to that as well, and that's totally fine. It's not mentioned in this book, but it should be probably. Then the device must be a standalone unit, right? This is not something that's going to have extra parts that need to be added to it. You buy this thing, and that's all you need to make it go. And then the total cost of the device should not exceed the given budget, $200. So sometimes the cost requirements are given as a selling price requirement. Sometimes they say we want it to sell for this much or not more than this much or not less than this much. Sometimes they give you a range. Sometimes they give you an actual budget for how much you can spend to make it. And that's what they've done here. The cost of the device should be less than $200. Sometimes they'll give you a requirement that the total cost to me to hire you to do this project should be less than this amount. Because $200 is not going to cover engineering costs. It's not going to cover engineering time. It's not going to cover testing and breaking prototypes. So maybe they say $200,000 to develop this design. And I want to be able to manufacture it for less than this amount. So those things are often included in this as well.
For this project, everything we do is going to be for charity, so. Or I guess.
For this project, you're doing something for the university, and they do have specific numbers they want to reach. So you can just talk to them about.
Price wise.
Yeah. So price and his requirement is that he would like to make it as cheap as possible.
Mhm.
So you're doing something and trying to make it as cheap as it possible.
That's kind of a relative thing, right? Because how do we know what is, well, theoretically, the cheapest way to make something like this?
Yeah. So for example, in your specifications, it's been specified that you use an Arduino.
Yeah.
For the very specific reason that they're available anywhere in the world. Using the Arduino with that requirement in mind, what is the cheapest way you can use an Arduino to do this job, right?
Or
So there's going to be a definite price point. The price point of an Arduino is about $5 for the Arduino itself. You can probably pick one up for about $5, $10 somewhere.
Buy in bulk,
Can you, yeah, and if you're buying bulk, you can get them cheaper. And then, what parts can we do this with the minimum, you're really looking at this. You've got a very open-ended price requirement essentially that says, how cheap can you make it? Eventually, once you've done it with an Arduino, you can redesign it and actually maybe use a custom chip that's a lot cheaper.
It's a lot cheaper.
Well, yeah,
Chip-
a chip that's cheaper.
That's why you gotta have a lot of units to make it actually cost effectively cheaper is
Yeah.
mass producing like
Yeah.
5,000 pounds.
Well, and mass producing these chips these days is not that expensive, even for short runs. So
They
It's-
could even get circuit boards made for you to.
yeah, they can actually they can pre-populate the circuit boards and wave solder them and everything else. So yeah, so those kinds of things can be considered at this point as you're thinking, what can I make it cheaper? But those actual decisions will be made later on in the process, right? Whether or not you're going to actually do anything like that. So this is the way that you organize the information that you're getting from your client. After you've taken the job, you're going to go meet with your client, or you're going to talk with your client in some way and get specifications, get measurements, get requirements, ask questions to make sure that you know what they want. Oftentimes, this is a time to go and maybe they've made a drawing or they have a CAD design of what they want, and maybe you get that information from them as well, so that you can use that as a design. If you're doing something more like with building something, then maybe you look at the building site, or you look at other things that are associated with this building project, or whatever, so that you have an idea of what's really going on. The last thing you want to do is pick up too little information rather, and design something that's completely not going to work for the situation because you just didn't gather enough information. You can easily gather too little information in this part of the process, but it'll never hurt you to have extra information, because if you don't need it, you don't use it. But if you do end up needing it, it's there, right? So, going from this specifications list to some kind of or a design brief specification list, whatever you want to call it, to some sort of an organizational chart like the objective tree is quite important here. Not only are you going to gather information from your client though, but you should also realize and remember that you can always look online. If you have a question about something, you can go and do research online in many different places. You can go to other companies that have made similar things or do similar kinds of work. Or you can go to, let's say that you're making a device that helps people in wheelchairs to sweep their floors, right? You can go to the ADA website, the American Disabilities Act website, and you can go look up requirements for people in wheelchairs. You can look up measurements of wheelchairs that way. You can look up a lot of the information you need without asking the client, because sometimes the client doesn't know everything. Maybe they know what they want this project to end up like, but they don't know the measurements of the wheelchair. They don't know the biggest bump a wheelchair can go over, or they don't know this, or they don't know that. They don't know building codes for building a building. They don't know, clients don't know everything. They just kind of have a basic idea of what they want the project to end up as. So use the internet, but try to use credible sources. Don't just search, just don't say to your phone, hey Siri, can you tell me what the code is for building a roof on a house, right? Actually go to the ASTM code website or talk to a professional engineer or something like this and get the information from a credible source so that you make sure that you get good information. There are many credible websites online for this kind of thing. They're not usually the social media looking websites like the blogs and things like this. Usually they are websites that say, you know, this is the official website for the so-and-so, so-and-so, you know, and then they have searchable databases that you can get your information from. And that's usually what they look like. Okay, so that is the beginning of this week's stuff. We will continue this into chapter 5, where we're going to get more details for the project and organize those details. This seems very repetitive, I know, but it is very repetitive. The process is get general information and then more specific, and get general information and organize it, then get more specific information and organize it, and get more specific information and organize it. And we do this over and over again until we have every bit of information we need to actually make a design. And then we design. That way we don't have to start designing and stop the design process to go and find information, because we've already found the information and we've already got it organized, right? And then once we finish this gathering of information and organizing information and getting more and more specific and more details, then we'll get on to actual design. During this process, we will do a little bit of design too. Our organization is part of the design process. And we'll see how that comes together a little bit more on Wednesday. So we will see you on Wednesday, and that's it. That's all we have for today. Okay, so Hunter, what is your question?
I just have some questions about the logbook and that presentation from a few weeks ago.
Yeah.
So I can never figure out how to like record the presentation on my computer.
So what presentation software are you using? Just PowerPoint?
Well, I used Google Slides.
Google, okay, Google Slides. Okay, so let's see here if we can so if you go to Google and you do and you ask it record presentation on Google Slides. There's quite a few websites that'll tell you how to do this. Google itself has one. I think the one I used was this one. But what you're going to do is you're gonna start using the presenter view, and then no, that's not the one. Sorry. Yeah, right here. Here, Vimeo has a video on how to do it. But actually, if I just open it up, I think I'll be able to show you how I do it. Let me open up Google Slides really quick. Here's my drive. Okay, so here I'm pretty sure I have a slides presentation here somewhere. Maybe. Apparently.
Here, this Kativo, his last name or name?
Abia is his first name.
First name?
Abia, yeah. Abia.
Abia.
Sorry. I'm just gonna have to open one, I guess. Let's just make a new one here. Actually, here's a PowerPoint I can open up. So it's gonna open up a PowerPoint, but it'll use the same tools, I think, as slides does. No, maybe not. Yeah, here we go. I can open it with Google Slides. File is too large to open. That's not good. Let's do, go back here. Okay, I'm just gonna open up a new one. Google Slides. Okay. So once you're in here into Google Slides, you should be able to go to, that's grid view, film strip view. Here we go. Go over to slideshow and go to presenter view like this. So once you open presenter view, it is actually recording you. And what it will do is it will record your slides, and I think it puts a little picture of you on the screen as well. But then every time you go to the next slide, it actually records the next slide and it's recording your voice. When you're done with it, you close out of it and it will save a file to I think it actually saves it to your Google Drive. And then you can share that file with them.
Okay.
So you go over here to, oops. Where did my, can't find what I'm doing now. Cancel that. Anyway, yeah, you go to presenter view, which is up in the right-hand corner. And then it will record for you. The other ways to do it depend on the kind of computer you have. And those are all listed in that Google search that I did. If you have a Windows computer, you can download an app and you can use a screen recorder essentially to record you doing this. And it's a free application. There's two or three of them out there that are pretty good. If you have a Mac, you can just use QuickTime to do it. I don't know if you have a Mac, but if you have a Mac, you can go to your app launchpad here and you can just jump down to others, open up QuickTime Player. And then when you're out in QuickTime Player, you hit file and do screen recording. And it'll record everything on your screen, and then you just start your slideshow and record that. And then if you're in PowerPoint, it's similar to Google Slides, but it actually has a button for recording a presentation under the presenting modes. So
Yeah, I'll just try using QuickTime.
okay, yeah, QuickTime works really well.
Okay.
So you're running a Mac, I assume. Then?
Yeah.
So one of the things that I would do if I was you, is I would open up two windows, two different apps. I would open up the Photo Booth app, which just puts a picture of you on the screen like this.
Okay.
I'm gonna minimize that down as small as it'll go in your corner or somewhere out of the way of your presentation, maybe upper right or lower left or something. And that way you have a picture of yourself on the screen while you're talking, and then open up QuickTime and record the screen and start your presentation. That way we can see you on the screen as well as your slides.
Yeah, sounds good.
All right. Any other questions?
I don't think so. I thought I might have some questions about my logbook, but I think I got it pretty much figured out. Like there was an example of the Gantt chart on there, and it had like, let me just pull that up. It has, so like, it has a Gantt chart and it has like numbers, which says like design process, and it says brainstorming, and then like part list. Is that like how much time they spent on each thing?
So that, let's see, which example was that? Which logbook? I can't remember. It's not this one. This one maybe. Yeah, so this one right here.
Yeah.
So when they were doing a robotics thing, they were building the the kind of moving parts of a robot that they were supposed to be able to pick up a ball or something like this with this robot. And so they're very general here in their tasks. I might have been a little more detail in my task, but this works fine. I would give full credit for this. Their design, so they're putting their design process here. I wouldn't call that a task. That's not a good task because this whole thing is the design process. But brainstorming is definitely something that you want to do. And so they're essentially saying that they're going to spend 2 days or something like this brainstorming about the project, right?
Yeah.
And once they've got a design in, this design process one, if it's going to be there, should be the whole length of this because it's going on the whole time, right?
Mhm.
So brainstorming will be part of that design process essentially. And once they've brainstormed a good design, then they would go to a parts list, and here they're saying that they're going to start report writing at the same time, which I wouldn't put at the same time. You have to do something before you can write reports on it. But you could say, I mean, if you really wanted to be super detailed, more detailed than you need to be, you could say, write in the logbook after, or each one of these things. But I like the fact that they've got multiple things going on at the same time. Here they're making revisions and corrections and final things and things like that. That's totally fine. Like I said, it's a little too general because I would like to see a little more detail here. Instead of just brainstorming, maybe they have 3 different things. One that says brainstorming for design ideas, and then another one that says sorting through to find the best design ideas, and then another one that says connecting all the best ideas together to make a product, kind of thing, And you'd use shorter titles to represent those things, but that would cover all of this. And then when you were done with all that, you'd be ready to find a parts list for the best design that you found, the best design that you put together. Does that make sense?
Yeah.
So that's kind of what's going on in the Gantt chart. In this other logbook here, this one has no Gantt chart in it, but it actually does have a nice specifications table, which we talked about today. And it also has what we're going to get into pretty soon here, which is the morphological chart, which has a lot to do with the brainstorming. In this particular group had to figure out a way to make the robot move. And so they said, well, one way we can do it is with wheels, and they came up with 4 different types of wheels that they could do this with. But they also said number of wheels, and then they came up with tracks as a different version here. And then they how they were going to power the wheels. Were they going to power the front or the back or all 4 or whatever? Then different materials for the wheels, different shapes. So they came up with, as they were brainstorming, they came up with lots of different things, and some of them are obviously not going to work that well, but some of them might work really well, and they were maybe ideas that just came from talking about them, right? From this kind of a chart, they would choose the best options. They would say, oh, well, I like this option for the tire, but it wouldn't work so well with this here. So maybe we go with this one, which is the second best, or this one, which is second best, and we go with this. And they essentially try to grade them all and try to figure out which one's best. And that's all part of the design process that we're getting into here pretty soon. And it all starts with making these lists, organizing these things in these charts. And if you go back even further, it starts with organizing what you think you're going to need to do in the Gantt chart, right?
Mm-hmm.
So the basic things, the general things you think you're going to need to do, we're going to need to sit down and do some research, and that you could include brainstorming that. We're going to do some research. We're going to, and you could even say that one group, I've got 2 people in my group, and one person is going to research companies that have already done something similar, and another group is going to research all the possible, I don't know, users that might use this or something like that. So we get information from them or something. And then and then so that's just your research thing, and maybe you think that's gonna take a week. And then you go on to the next big thing after research, which is design, we're gonna design this thing. And we'll call it preliminary design, then we'll do final design. So you do preliminary design, and then you do final design, and maybe you're gonna have to report back to maybe if when you've got a final design, you have to report back to the client, and so you put that in there. And then maybe you're gonna have to revise your design after the client feedback. And then you're gonna build your prototype. You're gonna test your prototype. You're gonna fix your prototype, for the things you find wrong with it, or improve your prototype, whatever. So those are all tasks that would be included in a design process for something.
Okay. Did you say that there should be a to-do list in there too?
Yeah, so the task list is what you build your Gantt chart from. All those things that I mentioned are all things that would be on your task list.
Okay.
So those two things are the same, they contain the same information, but the task list is just a list of things with times, and the Gantt chart organizes that list into kind of a schedule.
All right.
All right.
Yeah, that sounds good.
All right.
If I have any more questions, I'll email you.
Feel free.
All righty. Thank
See
you.
later.